We introduced a vector field so we could describe spin 1 field with a 4-vector mu of x. We started from classical equation of motion, and we showed that the Klein-Gordon equation for each of the components of the vector field, together with the constraint to reduce the number of degrees of freedom to 3, led us to an equation of motion, which we then used to build an expression for Lagrangian. And we found the sum of two terms. The first term is a Maxwell-Lagrangian of electromagnetism, which we recognize when we introduce the electromagnetic tensor. And the second term is simply a mass term. We then wrote our path integral in the form of a Gaussian integral, and which we could then solve exactly. And we found that the change of the phase induced by the source is expressed as we had in the case of scalar field, but now we have Lorentz indices for both the sources and the propagator. This propagator obeys an equation which is a bit more complicated to what we had in the case of scalar fields. So we use the Fourier transform to simplify this equation, in particular to change the derivatives into momenta. And we found an equation which is then simpler for the Fourier transform of the propagator. And we found a solution to this equation for non-zero mass.